Okay, so Developer Efficiency 101. Albert and I are excited to share this. Can we make this go away? Pretend you didn't see that. So we're thinking about how to kind of structure this presentation in ways. This is, we're getting some specifics, but in another way, this is kind of kicking off a series of tech trainings that are going to be occurring with First Fridays. And starting at the very top level, what I want to talk about is our intention and what I want all of our engineers to be, which is a 10x engineer. That's someone that is amazing at producing almost in a quasi-supernatural way. When you're dealing with a coder that is amazingly productive, it is like watching, Mozart. It's someone at their device, and they're taking a bunch of factors and combining it together in a very, very productive way. They're looking at it from a technical perspective, they're looking at it from a results perspective, they're looking at it from a UI perspective, they're tying it all together and really making huge impact. And that's what I want for everyone that works at NextJump. I want to have a team of 10x engineers. I want everyone here to feel and understand how their skill set is so above average because of their experience here that we can, individuals do more than teams of people. That teams do more than our team of 3 people can do more than a team of 300 people. That's what we want. That's our ambition. That's being a 10x engineer. Now, 10x engineer though that's a little bit of an amorphous term. What does that really mean? It's like what the HPI Institute is like human energy. Like they spend a lot of time putting metrics around what does that term mean? This is another one of these terms. I think a lot of what James I think was doing with design is trying to put in a framework around what does it mean to have an eye? What does it mean to look at something and make it say, oh, that's beautiful? How do you parse that apart into a learnable skill? So in thinking about 10x engineers, there's really 2 main dimensions, 2 main aspects: speed and quality. When you're a 10x engineer, you're able to build super fast, code super efficiently, but you're also able to build things that are architecturally minded, super robust, scalable. You're able to combine both of those sets and have the judgment when to use one versus when to use the other. We talked about this before. Most of us bias though in one way, or one way or the other. That we tend to be, for example, very speedy down here, but the quality, the robustness is often not there. What we call a hacker. That's someone that's really concerned with getting stuff done. That's really outcome driven. That's excited by the user experience of seeing that happen. Make sure those tickets get sold, and people have get that positive adrenaline rush that people are using your product. People tend to, a bunch of us tend to bias there. On the other end of the spectrum is the philosopher mindset. These are people that tend to code slower, but the robustness is there. They tend to build out things that are really scalable, are architecturally very solid, reusable by other teams, which is awesome. You get a big rush from building something that is like architecturally very cool. Once again, and then of course, where you don't want to be is kind of slow, low quality, and that's, to be honest, that's where most of us start out. So the mission is, how do we get everyone to be a 10x engineer? And I think it does boil down to those two kind of attributes: being able to be architecturally minded and kind of fast at the same time. I think a lot of the work that Albert and I have done over the years, and for this talk, we've really coalesced our thoughts and actually spoke with a bunch of engineers at NextJump. We talked to people, and to be blunt, we kind of put everyone in one of these buckets, and we're looking at what are the attributes, what are people very specifically doing that make them 10x versus others. And I think a bunch of interesting things came out. It's worth taking a note on them. In the hacker mindset, for example, we heard this a lot from people that are, a bunch of us are just super fast coders. They get stuff done in an amazing way. But they tend to have this fear of not hitting goal, very kind of outcome over process. And there were two themes that we heard. One is this fear of complexity. They're afraid to get started with a new technology because it'll slow them down. They won't hit the goal. However, if you're able to give them enough information to get them started, then they can start hacking away. So it's important to, I think, make it easier to learn new technologies. And that's something I'll talk about in a few slides. Another theme we had was that they have no time, they're too busy to do, right? The other side here on the philosopher mindset, heard this almost universally, that people feel burned by having operational load. So they build something in the past, they didn't make it very robust, and there's a daily or weekly operational load to maintain that thing. Oh, I don't want to feel that anymore, so I'm never gonna hack something together. So they've gone so far down the spectrum of being afraid to build quickly that they're only building robustly. And like I said, we all kind of bias in the same way we have a kind of an arrogant, insecure bias. I think in engineering and coding there's a kind of philosopher hacker bias. They each have their strengths and weaknesses. But understanding what those weaknesses are and solving for them, that's how you get to the 10x level. As I said at the beginning, our goal is to get everyone to the 10x level. And that's kind of the driving force between First Fridays and other trainings that Albert and I are working on, is to kind of use this framework and make that how we're developing the training and coaching and mentoring. Another thing we're going to do, what came out of this and what we're sharing now, is really some specific things around tools, techniques, tips for how do you actually code with more effectively, more efficiently, faster, but with an architectural mindset at the same time. So we'll share that in the second half of the presentation, the specifics Albert's going to go over. But this is just a V1. Out of this, in fact, using the app itself, we'd love for you guys to actually submit ideas, submit comments. We're going to make this an open wall. How do you become more efficient? How do you kind of think about things in a smarter way? So like I said, it's to be 10x, it's about architecture, and it's about kind of being efficient. I want to touch a minute on architecture in our next jump stack. For the non-business people in the room, can you guys hear me in London? Just heard you're good? Okay. For the business people in the room who may not understand that term, what a stack is. It's every technology company has a stack. Every web technology company has a stack. The term that became popularized a bunch of years ago with the quote-unquote open source stack, the LAMP stack, Linux, Apache, MySQL, PHP. I'm not exactly sure where it came from, but if you physically look, especially in the early days, even at NextJump, when you looked at our web server, it was literally a stack. So you have this cage, and then there was at the very bottom, there's the machine running the database, and there's a machine running the application server, and there's a machine running the Apache web server. So it's literally a stack. So nowadays, things are more sophisticated, and the way we deploy things physically, like an actual devices and actual machines, may not mimic this exactly, but logically, this is the same thing that's still happening. So from a historical perspective, let me take you through what our stack is, and the core technologies that are part of it. So back in 2008, there are three levels here. There's the data layer, the services layer, and the front end. We just had two layers of our stack, 2 layers of our cake in 2008. We had Empire, which is our PHP implementation, going directly to a MySQL database. In 2011, we added the middle layer, this services layer. The idea was to take some of the business logic and add it into services. What services are is the ability to basically make commands. So these are basically input-output commands. You create a command to log in a user. The input is the ID and the password and the organization they're part of. The output is yes or no, you got in. By abstracting those commands, you're able to make the code much more readable, more robust, a bunch of benefits from it. So we first did that with Java, and then Redis as the cache, the data store for the middle layer. Back in 2 years ago now, we upgraded that to Java. People didn't like working in it, so very heavy to execute, slow to code. We had our Go or Scala bake-off in Go 1, which is, so today instead of Java we have called NextJump OS, which is our Go-driven, Go language-driven middle layer. So here we are in 2015. We haven't actually produced this view, this kind of simplified view, which I think the most powerful thing about it is this, that to be an engineer at NextJump, you should be proficient in these 7 core technologies that are driving this stack. And that's what this training program is going to kind of be based on. The roadmap is that everyone here should understand PHP and the Zen framework. So this is the web language that we use to produce the pages. JavaScript, CSS, and HTML. Memcache, so that's the production data cache. So instead of going to the data for non-engineers, ultimately everything is stored in the database. But often to actually call a database is a very heavy call, meaning it takes many, many milliseconds. And then if you do that too much, the whole website slows down. So what you do is create a very fast data store that temporarily stores information. So effectively what happens when you log into the website, we create a temporary set of information about you. Your kind of user information, the offer, all this stuff is temporarily there, and that speeds up the website. So to understand that, you need to understand how to code memcache. In the services layer, it's about our Go language. And then in the data layer, there's really three technologies. Is that right? The Redis, Solar, and T-SQL. So, sorry, there's misalignment here. The cache layer for the services is Redis. So all of our services use Redis as the caching layer. And then in the data layer itself, it's Solar as well as T-SQL. A couple interesting notes that are important. Our current preferred services implementation is Go. So going forward, all services should be built in Go. However, we do have 4 services implementations that are still in production and still doing critical things. So one activity that needs to happen is to really turn those off and actually put them all into Go. But they are in fact happening. There's a common Java services, was the original one, Bluefoot services, Jungle services, and actual PHP services. So all of those are still running, especially for newer engineers. So it's important to understand all of these different implementations. So probably important point 1 is around, this is our core set of technologies. This is what I want to make sure everyone is not just learning PHP or not just in the database, but it's in fact getting experience and exposure to all these technologies. The other aspect is we've gone through and created a V1 list of called gurus. These are people that are responsible for that layer of the stack, being the evangelist of it, the educator of it. Ultimately, I'd like them to understand the versions of it and make sure we're upgrading really progress the company technically with those technologies. So on the front end, PHP and Zen, we have Anil. These technologies of related technologies, JavaScript, CSS, and HTML. Artem, Mcache is Chris Weibel. Go is Hilliard. Redis is Chris. Solar is Lokia. So Lokia is going to jump up here and give a presentation probably the next first Friday. In T-SQL, Callian. We're kicking this off today as well. With, John is going to give a deeper presentation on Go. Actually asked Albert, I'd like Albert to speak to this slide, which I think is important, and he has a deep passion. It explains it really well, but it gives you some context in terms of what other companies have done with their technology stack and how that relates to what we're doing.
So this slide presents what happens when you work with PHP at scale. So we all think we're encountering problems for the first time and only we are having a specific problem. And the truth is that's never the case. When you work with PHP at scale, invariably 2 things happen. Your code becomes a mess, no matter how careful you are, no matter what your standards are. If you really, truly start building lots and lots of code, you have a lot of functionality. PHP becomes a mess. PHP is, as you know, dynamically typed. It seems like an innocuous thing. It's very good because it lets you go really fast, but it also lets you be very loose as how you define things. It makes your code very prone to errors. It makes it very easy that you have a lot of code to make mistakes because everything is not defined as tight as it could be. And so that you have the clutter and the chance of making mistakes increases, and then on the other side, performance. As you scale, you have a lot of code hitting the web servers. You all remember this picture of Twitter? There are Ruby on Rails. They kept going down and down and down over and over because the front-end service is getting crushed by the workload it can't handle. This has happened to every major company on the tech space, and they've solved it in different ways. On one hand, the Facebook approach, they tried all kinds of plugins to organize the front-end code, to annotate it, to do all sorts of things. Ultimately, it didn't work. What they ended up doing is creating hack language. I don't know if you've heard of it, but hack is a variation of PHP, essentially, that is called gradually typed. what they did is they created a version of PHP basically that it can be coded the same way you code today, but if you want to start defining every single variable, the type of every function, the type of every parameter, you can do so gradually. And you can have code mixed that is dynamically typed with code that is statically typed. And over time, they migrated all their code to be fully statically typed. And they did that through this variation of PHP. You could argue it's a new language. You could, some will say it's a variation. It's a philosophical debate. But that's their approach, basically, to solving the complexities with the front-end code. Other people that do it different ways. Twitter happened to do a rewrite starting in 2010. Amazon and Google went the services way. They created a services layer, and they start offloading code from the front end into services. So less code means less clutter, but also that helps with the performance. So essentially, that's the path we took. We sat down 2 years ago and said, hey, this is becoming really complicated. We have a lot of code, especially as one card started growing. We have a lot of code, and out of this, seeing the complexity increasing, we sat down and said, okay, how are we going to solve this? The idea was to help you all become more productive by creating a services layer at Go, where we can offload code and make it easier, better, higher performing. So otherwise, it's very difficult for all of us to keep track of everything and keep growing in this way. So that's the first piece, that aspect. The other piece is the standards. We've been losing the past with these. You're starting to see some of these become tighter and coming back in. The peer reviews, the formatting, the comments, all that is slowly making its way back in, and we're tightening all that. It's going to continue to tighten up more and more. We want to be something that's ingrained in all of us, and that these become fundamental, basic things that we all take care of on every piece of technology that we use. So, that said, pass it back to Tom here.
So, like I said at the beginning, the objective here is like training and development and mentorship on two levels, becoming like architecturally minded and fast and efficient. So what we just talked about is the basis of becoming architecturally minded. If you don't understand the core technology and how the stack works, you can't use Solar when appropriate. You can't use Mcache when appropriate. So what we started to do is this. So this, while difficult to read, we'll continue to iterate on it, is pretty cool. What this is taking is the number one most important flow in the site, which is buying something. So this is the one on the top. You're seeing the one cart purchase experience from coming to the site, being authenticated, browsing a product, putting a product in the cart, actually checking out, returning the thing, getting the points ordered to your account, getting the emails. That's all of these 14 odd steps at the top. That's what it takes to actually buy something. On the left side that's the stack. That's what I just explained a few pages ago. So the Empire and front-end caching, the services and its caching, as well as the data layer down below that. The very interesting thing is that if you take any one of these slices, we've actually documented what's actually happening. So when you add something to the cart, for example, it's actually using one of the NextJump OS, the PHP services in order to do that. It's storing that information in TB cart. I can't read it there. TB cart current, right? So we've actually documented this. So the most fundamental flow of the site is kind of buying something. There are other important flows of logging into the site, affiliate transactions, that kind of thing. But by doing this, a couple things are happening. One, I've already described how we're putting kind of gurus in charge of individual kind of technology layers. But now, as an engineer in charge of one card, for example, putting people in charge of actually understanding that vertical flow and making sure everyone else understands it, and the whole thing is uniform, and that there's no area of the business where someone is the only person that understands where is that critical information stored and where is the processing taking place. So this is also by Albert Nye's office. We'll continue to be iterating on that. So what's coming next? We have Zend. This is the type of thing that's coming next. So in Zend, the Zend framework, for example, so that's at the top layer, part of PHP. Most people here don't understand that very well. Some people in the architecture team do, but most others do not. For example, what are the core files of Zend itself? What actually happens in the configuration.php and bootstrap.php? Bootstrap.php runs on every request, so every page view it runs. What is it actually doing? The controller PHP, how does that actually work and direct the specific page to the right place? So we're actually going to discuss that and figure out so everyone understands how all of that works. Solar in depth, it's something Lokia is working on. How do you configure your VM to be able to actually code in Solar? How do you call index and build indexes and calling indexes? How do you optimize it? So these are the sets of training that are coming. We really have 5 aspects that should be communicated in each one of these trainings. One is just kind of the basics of it. How does it work? The second is the setup. How do you actually get the thing up and running? It's kind of so it's theory and setup. 3 is application. How do you actually build something? 4 is documentation, and 5 is deploy. How do you actually deploy it specifically at NextJump? That can be a big stumbling block, especially going back to the hackers. One thing we heard a lot was that people, if they're using a new technology, they can kind of figure it out, but then they don't know how to actually deploy it onto the NextJump platform. And the deploy procedures are different depending on what technology you're using. What I'd love for you guys to do is to use the app. We're just kind of bring it up now so you're ready to do it. What technologies are people most interested in? We'll use that to guide the next set of trainings. Is it Solar? Is it front end stuff? All the stuff that we've listed here. What's most interesting for people to learn about in depth? So that was about being architecturally minded, what we just talked about. To be a super productive coder, you need to be able to think in architectural terms and do it quickly, understand all the bits and pieces of it. Now the other half of it is to be efficient. So it was totally interesting to go around and talk to a bunch of engineers around what tips and tools and techniques do they use to be efficient, which is, I'll hand off to Albert to talk about that. But it boils down into 2 things. People that are super fast, they have little almost mechanical things that they do, like setup of their machines and environment. So we're coming up with those tips. The other is kind of mindset stuff. How do they think about coding in a way that's more efficient?
This is intended to be a beginning point, the start of the list that we want to build with your app. So this has a combination of things that come from Thompson experience, years in the industry, as well as some that you suggested yourselves. So as you see, these are incomplete lists, and we envision them growing and turning into an open white wall in a list that we all share and all as a team use to become more efficient and do better everything we do. I'll go through some of these. This is the first one. This is on the aspect of coding itself. As you watch people code, there's 2 different modes. You can watch someone go click, 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 and then get something done. Or you can watch someone that they're like a virtuoso on a piano. They're literally going like this, and you can't even see their hands as they're opening and navigating the entire system. And you probably, people in mind yourself, you've seen do this. So our intent is to collect the best cheat sheets, the best tricks for every IDE and every editor, and share them across to get everybody to get to that level. We want to build the knowledge base to people who do this and get everybody to be able to do the same thing. So the productivity jump is enormous. People use hotkeys, they have macros that they run every day when they start up their editor. There's a ton of stuff and a ton of already existing knowledge that we can share to get everybody more productive right away. It seems like a very simple thing, but so we keep hearing this over and over. It's one of the most important things. Navigating your file system in the computer. Learn to find files or find text in files. It's like hacking. You need to change something somewhere. You don't have time to understand where the file is across thousands of files. Find a piece of unique text and you search for it. You need to be able to do that fast. You can do that sometimes through your own editor. Sublime may let you do that easily. Sometimes you need to do it on the command line. You need to learn. It's very simple, basic commands. Those 2 here are tremendously useful. You learn them, you use them all the time. You can also accomplish the same thing with other add-ons and tools. with a suggestion to use this tool called App. It's like a tool like Rapid for a program that's specifically oriented for code. So that's a good way to do it as well. So this is a mindset, a framework on how to think of when you're about to start implementing something, how to think about it. It's the 40-20-40 rule. You should spend about, it's not exact, but about a good chunk of time, over 40% of the time, reading what's already in there, understanding how it works, and thinking about how you're going to architect your code to build what you need to build. You may want to draw simple diagrams on a piece of paper, share them with others, little boxes, and connecting them. 20% of the time actually coding, and then 40% getting feedback and refactoring what you did, what you understand. This is what I call the 70% rule. Okay? It's a draw from my own experience of this. If you worked with me before, you've heard me say this a lot of times. It's really bad when you build something just to 70%. Why is that? You build it to 70%, it kind of works, it quasi-works, and it does more or less the things it needs to do, but it's fundamentally still broken. You build it to a point that it's kind of working. So you intend to go back and finish it, but the truth is, if you build it to 70% and you stop, you never go back and fix it. You have to either build it less, so you have to go and do more, or get it beyond 70. Otherwise, I guarantee, whatever you build to 70%, you never go back and really complete the product. And then it stays lingering with broken features forever. This is a simple one too. It's our principle of launching quickly, iterating like hell. And this image you've seen before, courtesy of the Spotify team, right? So we want to build complete usable products fast. So we don't want going into a back room and waiting for 3 months and then coming out with a finished product. That's just not how we operate. We operate building individual products that work by themselves, even if they're limited, even if they don't have the full scope, even if they have issues. But we want to build in an agile way incremental products. If you want to build it the way that it works at the top, you should be working at MasterCard or a financial institution. We never build products like that. We're not planning to change it there. Very simple. I heard this from a number of people. There's actually a lot of studies that back this up. Keep your desktop clean and nice. You walk around, you see people with these massive desktops with 1,000 files on them. If you keep it clean, it actually correlates to messy code. There's a few studies done on this. You keep your desktop clean, then you code cleaner your own code. Also, many of you already do this. We have a number of suggestions. Use a dark background. You're many hours in front of the monitor. No bright images, no colorful things. Your editor, your desktop should be very dark. It's easier in the eyes over time. You can also dim the brightness of your monitor. You walk across the floor, and some people, and when they make it, it's so dim you can't even see what they have on the screen. But just people evolve in that way to have less glare, and it's also better contrast. Very simple too. Group the things you use easily in one single place, so you can just start. Everything is one click away from what you need. It's an example of, if you're in Windows, you can do it through the toolbar. It's an easy way. You create 2 toolbars. Example of my desktop, I have all the tools I use in one place at the top left. Those are all my frequently used apps. And then all my shortcuts to different paths or scripts are at the bottom in another place. So it's a really easy way to keep everything in one place. If you're on Windows, I'll touch on the taskbar also. You'll notice always in my computer, the taskbar is wide and on the left side. So it's something I suggest you may try. That thin taskbar at the bottom comes from the very early days of when Windows launched. When Windows launched, people were in 14-inch monitors, not a lot of real estate. Microsoft had to come up with a tool that didn't take up a lot of the screen. The screen wasn't that big. And so as an artifact of that toolbar remained at the bottom as a thin strip forever, even though people started working with 15, 17, 19, we're at 24, and 27, and 30-inch monitors, and you still have this really thin strip. You can make that do more. You can make it wider, make it taller, you can put it on the side. It allows you to have, if you have 15, 20 applications open, at a glance you can see the one you're looking for and click on it. If you have it horizontally at the bottom, they become really narrow and hard to see, and hard to get to what you want. So just a simple thing. So another simple rule. This rule is about improving everything you touch. These are mindset things, right? So, Boy Scout rule. When you open a file, if it's missing a header, add a header. If it's missing a comment, add a comment. If something is not well understood or defined, just comment it out and explain it better. Whatever you see is missing there, touch something, leave it better than you found it. It's what I call the psychopath group. Okay? When you are building something, you should code as if the guy who's going to maintain it will be a dangerous, crazy person who knows where you live. So if you keep that in mind, I guarantee you're going to do a better job building everything. Code, make it easy to read, easy to understand. Don't make it messy. So keep that in mind. Correlating to the simplicity, when you start something, create a real simple plan, but have both pieces, architecture and the plan to get it done in mind. We tend to go all the way extreme to the left many times. We have no plan, no architecture. We just like, we'll pack something together. It's too extreme, and on the right-hand side, we don't need a big plan. We don't need to abstract everything out from the get-go. We don't need to optimize and try to get everything right from the beginning. Just a whiteboard and a rough plan. It's very simple. Also, if you get stuck, it's typical for engineers and coders to see that this is the stigma, right? The Mountain Dew is piled up. We just power through everything, whatever it takes, sit down forever. But if you get stuck, it's way better if you step away and do something else for a few minutes. You go to the gym, play ping pong. It's tremendously useful because in the brain, what happens is it actually keeps churning in whatever you were working on. And when you come back and sit down, you may then have a lot easier time coming up with a solution. Have pet projects. Find this very valuable on a personal level. Just do something. Install Redis at home. Install Solar. Try to build something. Just have fun. Learn another language. Learn C, for example, if you want. I know it's like an old language, but guess what? Redis is built on C. Memcache is built on C. Or learn Java. Solar is built on Java. It's going to be really good for you. If you're in this career for the long term, you want to learn some of these basic building blocks. The last thing we have in here is instrument your code. I find this tremendously useful. Again, these seem like very simple things, but if you sit down, before you start coding anything, you think, okay, how will I be able to tell easily if this is working or not? Because oftentimes what happens is you build it, and then when you go back and think, okay, let me see if it's working, you end up pulling together, processing tons of stuff in mlog, and joining to 7 other tables to understand if your code is doing or your application is performing the way it's supposed to be. If you think up front, it's going to make you insert things in there to easily tell at a glance whether the thing is doing or not. You may create a different table. You may do a caching intermediate step to group things to some things. That's going to help you a lot here. So I'll pass that down here for the closing thoughts. It's just a start of a building set of tips that we hope to keep you building.
So, like we said, just to summarize all of that, kind of the theme here is like, let's build 10x engineers. That's our intent and the guiding force behind what we're talking about, what we're building out from a training point of view. So we're putting all the stuff that we just talked about on the walls outside Albert's and I office. We'll put it on a dashboard as well. But really, we want it to be an interactive process of like just keep refining this and refining these lists, getting more ideas and tips to get people efficient. And the third thing is what we talked about at the beginning. Actually, making this event in particular, a big part of that is actually training about the technology stack, making sure everyone knows all those 7 core technologies at a minimum. And this is just the start. This is very focused on the mental aspect of engineering and how do we just become more fast, more efficient, more awesome at what we're doing. So with that said, we can open up the floor to questions. Should we start in the UK?
Yeah, thanks, Tom.
Sure. Nothing? No questions?
Hey Tom, this is Andreas. I've got a quick question.
Yeah.
So one of the struggles I found personally is that with all these different like services, especially in the services layer you mentioned, is that I found out that there isn't any documentation in terms of we don't know where these services are stored in terms of the repositories. So even if I want to help someone from like the tracking team or something else make it better, then I don't know where the resources are for me to start doing. So I'm just wondering if there is any thoughts from your side into gathering all the information together and documenting it, so like everyone can have access to it if they want to.
Yeah, totally, 100% on the same page with that. And that's the idea of the gurus, and then them putting together like that diagram I went through showing what happens with a one-card transaction. That's showing how these services are implemented and where they're implemented. So the combination of those two things, what the guru is doing, if over here, for example, I saw an early version of what Lokia has put together, which is basically those 5 things I talked about. It's how to get started, how to actually develop an application, where the documentation is, how to deploy it. I'm missing one of them. But that information will allow, it is missing. All that information needs to be on the wiki or otherwise. So like, just like you're saying, you can understand where it is, what it's impacting, and can very quickly go and start helping. Like people want to, like I see that all over, like we all want to help. There are areas where I want to help in, but I don't know enough, and I should be able to very quickly educate myself and jump in just about anywhere.
The short answer is yes, we're aggressively working to make that happen.
Boston?
If there's any questions.
You're in New York?
So this slide stuck out to me a lot because of the large list of deprecated services. But mine being one of them. And I was, I mean, this reminds me of I was watching John Oliver the other night. They were talking about infrastructure and how important maintenance is. So maintenance isn't sexy, and we're engineers, and we get a rush at building something new. How are we going to integrate into our culture a more mindfulness to maintenance and cleaning up and, you know, bringing deprecated services up to where they should be, you know, in the present stack? Like, how are we going to make that part of our culture when what our culture has been build fast, iterate like hell, build something new?
Because we're definitely indexed on the hacker side of things. So part of this is how do we, it's not to get rid of that, but it's to balance it with the architecture side of things, with the philosopher side of things. And the two, I guess, basic immediate steps we're taking are on this page. One is simply providing visibility into what exists. We don't have visibility into it. And number 2 is putting people in charge. So these names, we haven't quite talked to people. So Hilliard, for example, you're signing yourself up for, or we've signed you up for a lot of work here. But it's really to put people in charge of these. No one's in charge of them, so no one has responsibility for. It's not that they need to fix it themselves, but at least provide the leadership for getting things to.
I think a lot of mentality is also around like, okay, I'm never going to touch this part of code or this part of the stack. Like, why should I even bother learning it? And I think, as you mentioned, like part of being a next jumper engineer is knowing all of 7. But like, how do you, like, how should we change that mentality?
I guess I think it's if someone doesn't have that mentality. So to repeat the question, Nine was asking. Some people may not want to learn these other technologies. Basically, they're happy doing what they're doing. I would say in the next jump ethos of growth mentality and growing yourself as an engineer, that's not an acceptable kind of mindset to have. And I guess I haven't actually heard that. I've heard 90% the other way, that people are bored or kind of they maximize their knowledge in one area. They're like dying for an opportunity to practice in the other area. So I think that's like more common.
Definitely. Can I add to that, Tom? And so I think what Tom is alluding to is the fact that we believe our flavor of 10x is being a more complete, we truly believe this from the inside, being a more complete engineer, a rounded engineer that understands the entire stack is something that's very good, very beneficial for you for your entire lifetime. We really believe in that. That doesn't mean that you love working on part of the stack, but you can't specialize and do the majority of your work. And that, you know, if you love front end, if you love solar, that's okay. We'll have people who specialize and spend 60% of their time doing that. But we truly believe understanding the whole thing is to your benefit and for your growth as a person. In the same way that expands into understanding not only the stack, but also we have a unique scenario where we own everything from the physical, top down So there's no reason why you just couldn't expand into the server configuration, understanding routing, understanding all our hardware, equipment, IP space, everything we own. We'd like all engineers to understand that. And when you work on that day in, day out, other people may work on it. That enriches you. It makes you a more complete engineer if you understand it from the physical to the software. And then you expand that a layer further. That's why we want you to understand product and marketing beyond that. And so you understand not only technology, but you're more complete when you understand all three pieces of the puzzle: engineering, product, and marketing. You're able to make things happen in all those dimensions, and so on. And that will expand you to grow as a person and emotionally, and so on. But these are all like layers of an onion, and we believe it makes you a more complete, better person, regardless of whether you're here or you one day leave. You look back and say, "Oh my God, I learned a tremendous amount of things. I'm a better person now. I'm more complete."
That brought up another kind of not sequitur, but just thought of for the Boston team, DevOps, and in particular, I've heard a lot of people express a burning desire to understand our networking and physical implementation. So that would be an awesome first Friday thing for you guys.
I think it's a unique aspect. This is, I think, a unique aspect of Next Jump. We focus on this complete picture. If you look at Apple, they're all about polish. Facebook, they say they're about speed. So everybody has their thing. Our thing is we believe you can be a very complete engineer. There's no reason we need to pigeonhole into one thing or narrowly just learn one technology. We want you to be a well-rounded engineer that learns all the pieces.
Yes, anything in San Francisco?
I guess just more of a comment rather than a question.
Sure.
I think we all here will appreciate the intent to provide more transparency to all our different systems, and that's something that we appreciate going forward.
I think it's a big part of, as basic as it is, simply providing visibility into it and putting people in charge is like a significant improvement to the current situation. So I think with that said, this session is over. I'm going to transition to John Hilliard. Put together a kick-ass Go presentation about a month ago, so we're getting the condensed version of it today. So we'll switch over to Boston and cue John up. Cool, thank you guys.
John, I just give you presenter rights. Can you verify? Should I give it to John Hillard or T. Boston?
Are you an engineer?
Yeah.
Oh,
yeah.
awesome.
So like I studied.
Your business.
Yeah. Well, it's funny. Like,
Yeah, I'll take it.
Boards, like different
Okay.
stuff that I don't really understand. Like